What I'm going to cover today is the topics related to DNS and cybersecurity. Obviously, as I understand that you are mostly a community that who are involved with Kubernetes and the development work and so on. But the contents that I'm going to cover today, you may see, of course, I'm not sure whether it is really going to be out of scope, but I still think that it's something worthwhile for you to understand, obviously, because even in Kubernetes, that there are some of the areas that you may actually go into some of the DNS-related content, especially in service delivery and so on. So with that objective, we are going to cover some of the DNS-related concepts today, and of course, then we will try to relate that to the security issues that are actually linked to many of the DNS-related infrastructure, actually. So with that, yeah, I mean, it's a great pleasure, as I said, to talk to you. So we I was given like 1 hour or so. I will try to cover these contents within that 1 hour. We'll also have maybe 5-10 minutes or so for any questions if you have. But obviously, like in case if anyone is interested, even sort of getting to know more about some of these concepts that we are talking about today, I'm even happy to do some further sessions and get to more details as well. Okay, so with that, I also actually want to quickly touch on the organization that I work. You can see there's a logo here called ICANN. Let me also actually put my laser pointer. So ICANN is an acronym here, of course, that stands for Internet Corporation for Assigned Names and Numbers. If I just try to give a very quick sort of intro, what is our role in especially in DNS, I think that would make some sense, especially based on the things that we are going to discuss. So ICANN is a global body, and there are, you can also see there are some 3 pillars here. We call these as internet identifiers because, as you know, that when we try to connect any device to the internet, this device has to have some sort of an identity or an identifier. Now, these are the identifiers that you will encounter, of course, with the internet. You will see the numbers, of course. Numbers are like the IP addresses. And then we have these names. Names are basically the domain names. And then we also have these protocol parameters. These are things like, port numbers and so on. So ICANN's role is basically to coordinate these internet identifiers globally. And also actually, so ICANN is involved in a coordination role. And of course, then we work with a lot of stakeholders globally, and it's a multi-stakeholder body. And we are also actually, we also facilitate the policy development process as well in terms of these internet identifiers that we discuss. So that's a very brief intro, actually, from ICANN's perspective. Now, today we are going to actually focus more into this names aspect, or in other way, the domain names. Okay, now, as you all know, DNS stands for the Domain Name System. And so simply we call it DNS. Now, actually, DNS has been there basically the very first drafts or internet drafts were written about DNS over like 40 years ago or so, during early 1980s. So since then, there have been a lot of work done in the space of DNS, and many standards have come and so on. IETF, the Internet Engineering Task Force, they do all this protocol-related development as well. And again, it's all community groups. So there are a lot of working groups who are involved in actually setting these standards, developing these standards, and so on. So when it comes to DNS, now DNS is a hierarchical database. So you can see that even here, there is a hierarchy, right? And it's a hierarchical database, and also it is a distributed database as well. So which means when I say hierarchical, there's a proper naming structure within DNS. You can see this structure actually. Top of this hierarchy, we typically call it as the root. So whenever you hear the term the root in the DNS, that is actually top of this hierarchy. And then you have the next level here. And this level is what we call the top level. Generally, these domains are called top level domains. And then the next level is called the second level, and so on. So that's how the hierarchy goes all the way down. Now, these are, again, these are all namespaces in a way, or database components. And it is not necessary that we have to keep this whole DNS database in one server. I mean, that's not practical, that's not scalable anyway. So what we have to do is we're going to keep different components of this database or namespaces in different places, or in servers, basically. Those servers are called DNS servers. And so if you consider this hierarchy here, top of this hierarchy, we have the root. So the root namespace, or the root database, is kept in servers called root name servers. So again, if you're familiar with, if you've heard about some of the DNS related contents, you may have heard about root servers. So root server is simply the server that keeps the root database. In DNS terms, we call it as the root zone. So if you consider a DNS server that keep the root zone, that's what we call a root server. Then coming on to these top level domains, when the internet started, like very long time ago, even when I said when the DNS actually, the initial DNS RFCs were written, there were like 7 top level domains like .com, .net, .edu, and so on. Everything had a purpose. .com was meant to be for commercial entities, and then .net was meant to be for networks, and .edu was meant to be for educational institutes, and so on. So there were like 7 of those top level domains during like early 1980s or so. But then later, this top level domain space has expanded. We also actually saw that in 1980s or so, every country, of course, with the expansion of internet, every country could get a top level domain, and these top level domains are called country code top level domains, or simply they are called CCTLDs, country code top level domains. So for example, you are probably familiar that in Sri Lanka, the country code top level domain is LK, because this is an international standard. It's an ISO standard, ISO 3166 standard. Every country is given a 2-character or 2-letter code. For Sri Lanka, LK; for Australia, AU, and so on. So over the years, we have seen many countries also actually getting their country code top level domains delegated. So currently there are like close to about 300 or so. Now, then in more recent times, actually, like after 2012 or so, these new top level domains were delegated. these are in fact called, by the way, earlier I told you that these ones are called country code top-level domains, and these ones are called generic top-level domains. Like .com is a generic top-level domain, and these ones, like here I have something like coffee or .coffee, for example. These ones are called new generic top-level domains, or simply they are called new GTLDs. GTLD stands for generic top-level domains. So these are new generic top-level domains. These are generic top-level domains which existed for many years. These are country code top-level domains. Now, so that's why nowadays you will see it's just not only .com. You will see strings like .coffee, or there are all sort of different strings. There are, in fact, big companies who also have their company names as a TLD as well now. Now, also, actually, if you see here, there's another string here. This is actually ASCII code or ASCII string. These are called IDNs, or another way, internationalized domain names, because after, of course, during early 2000s, there were some new standards came related to IDNs, like in 2003 and 2008. There was some standards came related to IDNs. This is basically to have local language strings, because as we all know, if the internet has to be expanded to many parts of the world or many communities and so on, we can't only just deal with domain names in English. We should be able to have domain names in different scripts. For example, if you take in Sri Lanka, we should be able to have scripts in Sinhala or Tamil, like that. In China, we should be able to have domain names in Chinese characters and so on. So, but the only issue is that the DNS queries, DNS does not understand all these local scripts. DNS resolution happens based on ASCII characters like these ones. So that is why, obviously, like say, if this is a singular string, this need to be converted to a ASCII code. So that's why you see here that's an ASCII code here, and these are actually called internationalized domain names. So currently there are about 60 or so IDN strings have been delegated directly from root. So earlier I was talking about ICANN. So one of the important functions that ICANN is also involved is actually managing this root. So we have a function within ICANN called IANA function. IANA stands for Internet Assigned Numbers Authority. And within this IANA function, the root database or the root zone is being managed. So basically, root will delegate .com to a certain entity, .coffee to a certain entity, .lk to a certain entity, and so on. So I told you, like, these country code top-level domains are currently like close to about 300 or so. And even these ones, like the new generic top-level domains, there are over 1,000 or so now. So if you count all these top-level domains, currently there are over like 1,500 or so. And so that's quite a lot. So if you think of that original 7 back in the 1980s, now this top-level domain space has really expanded quite a lot, from like 7 up to like 1,500 now. So which means when this namespace expands, and the namespace expands, obviously, especially from a security point of view, also we need to take a lot of precautions, a lot of security measures as well, because for cyber criminals and so on, they have a bigger playing field as well for them. Say, for example, if someone wants to have some phishing domains and things like that, so there's a lot of space out here, especially even with these IDN strings. As you know, some of the in some languages, you will see similar characters. Say, for example, if you take English and a different language like Cyrillic, you have similar characters. Even in other languages, other scripts as well, you'll have similar characters as well. Even if you take French or languages like that, there are some characters which are very much pretty close to some of the English characters as well. So, for example, in the browser, sometimes a user may not be able to really see the difference between whether this is a English character or with a little hood or something with a different another language character as well. So this is why sometimes, especially when it comes to phishing attacks and things like that, we need to be very careful, especially in terms of figuring out, what sort of domains these are. And so that's a kind of brief overview about the current DNS hierarchy. And then in this case, you can see that .com has delegated another space called example.com. So this could be your company. Say, for example, this could be Platformer. So Platformer has got a delegation from .com. And then .com, of course, has been delegated from the root. And similarly, if you have your web server here, you will have, www, that's a label for your web server. Now, if anyone is really involved with more DNS administration, especially, the technical administration, you will deal with things called these fully qualified domain names. So fully qualified domain names are basically, you would just define the full path. So if you are speaking of this web server, that would be, the domain name would be www.example.com, and then you still have to specify the root here. That's why there's a trailing dot here in the end. So if you see this kind of a name, this is what we call a fully qualified domain name. But of course, when we type this in a browser, we wouldn't put this last dot, because it can interpret what we are talking about here. But when it comes to the things like zone files and so on, we will need to actually put this dot in the configurations. But there are some DNS administrators, they deal with a sort of a user interface, GUI-based user interface, like a cPanel or something. So they may not actually really edit the zone files as such. But if they want to add some records, they could be just adding, say, a web server record. They could be just adding this www.example.com and then just provide the IP address. Yeah, so this is just a sort of summary just to show you that, as I said before, DNS is a hierarchical database, and then also it is a distributed database. So when I say distributed database, say, for example, this root database or the root zone is kept in certain servers. .com database or the .com's namespace is kept in different other name servers. Example.com space is kept in different other servers. So we don't have to actually keep everything in one place. It can be all distributed. And even if you take, say, example.com, we can't, we don't just only keep that example.com only in one server itself. For redundancy and for scalability and so on, we will have some multiple servers, so that in case even if one server goes down, we can still have other redundant servers serving the that particular namespace as well. Okay, so moving on to the next slide. It's especially if you're dealing with DNS, I think it's good to know about some of these DNS ecosystem relationships as well, because especially if you have to deal with some of the security issues related to any DNS related abuses, domain name abuses, or security issues, you may have to deal with certain parties. And so you may need to know actually who are the players who are involved in this ecosystem. Now, here I'm highlighting actually some of the contractual sort of relationships, especially from an administrative point of view. And as I said, if you have to say if there is some cyber incident, or if there is some cyber abuse or DNS related abuse, you may have to actually deal with these entities. Now, on your of course, okay, I'll go from here. So I talked about ICANN before. So ICANN has got, I told you that ICANN would delegate, say, .com to certain entities, or .coffee to another entity, .lk, like, for example, in Sri Lanka, the domain name registry, like that. So with some of the entities, ICANN has got contractual relationships. So earlier I told you about GTLD, or the generic top-level domains, with the generic and the new generic top-level domains. So with these generic top-level domains, ICANN has got contractual relationships. So here you can see there's something called a registry agreement. That is actually what I was talking about. So there are some certain guidelines that these registry operators, whoever, say, for example, if you take .com is managed, the registry operator is VeriSign, and so VeriSign has got a contract with ICANN in managing the .com. But ICANN do not have any contractual agreements with countries as such. Say, for example, for that matter, Sri Lanka or Australia or any other country, because with those CCTLDs, country code top-level domains, ICANN ICANN doesn't have any contractual relationships, mainly because with a contractual relationship, you are sort of putting you actually giving a sort of a policy that to be followed within that national boundary, which can be a situation where that's something to do with the country's sovereignty, right? So that is why ICANN would not enforce any policy to a certain country as such. That's why we do not have any contractual agreements with countries or the country code top-level domains. But of course, there are some. There is actually a support organization within ICANN called CCNSO, Country Code Name Support Organization, which is not really shown here. So if the countries want to still be involved with the policy process, or if they still want to share some best practices in managing their registry and things like that, they can also be a member of this country code name support organization, and still contribute to those things as well. So anyway, I was just talking about that relationship. And then, so these are called the registries. And then the next level, you will also see these registrars. So this is something that you probably hear very often, because if you if you want to get a domain name, generally a lot of users would go to a domain name registrar. So there are certain big domain name registrars out there. So there are also some of these registrars. They are also ICANN accredited registrars. So what does that mean? Basically, they also have a contractual agreement with ICANN as well. So here you can see that registrar accreditation agreement. So they would sign this agreement, so that they will follow these policy guidelines and things like that. And then below the registrars, there are things called resellers, domain name resellers. Generally, these resellers, they have their own contractual agreements with registrars, because they are kind of an agent for a registrar. So they'll have their contractual agreements as well. And then finally, like, you have this, in this case, the user, or whoever the party that gets the domain name. Generally, those entities are called registrants. So if you, for example, like, you have platformer.com. So if you buy platformer.com, you are the registrant. So you can go and buy the platformer.com either from a reseller, or you can buy it from a registrar. And in some countries, of course, you can still go directly to registry, but generally that doesn't happen with the generic top-level domains. But say, for example, like in Sri Lanka, if you want to get a .lk domain, you can directly go to .lk registry and get a domain name. So even in that case, you will have some registrant agreement with the party that you are getting. So for example, that in this case, if you get your domain name from this registrar, you will have a registrant agreement with them. So this is kind of, I hope that this overview gets you some sort of an idea that what sort of contractual relationships exist in this domain name administration. And this is quite useful, especially if you have to lodge some, as I said earlier, abuse complaint or something. Say, for example, if you get some abuse from a certain domain, you might have to check actually, okay, who is the registrar who has delegated or sold this domain. And then you may have to actually find their abuse contacts, and then you will probably have to write to them. You may also have to see their terms of service conditions and things like that, their contractual agreement, and how they're going to take action, what sort of action they're going to take, things like this. These are what we call AUPs, or acceptable user policies. Generally, they publish in their websites. So it's worthwhile to read in case if you have to deal with some security issues and so on. Okay, so moving on to the next slide. So now let's get into a bit of technical side of it. Earlier I was talking about some of the administrative side of the domain name delegations. Now, in terms of technicalities, so earlier we discussed about these registrants, and then they buy the domain names from the registrars, and then you have these registries in the middle, like .com or .lk and so on. Now, they have to maintain certain databases, actually, because this information, when I say databases, there are a number of those databases as well. DNS itself is a database, I told you before, like it's a distributed database. So they will have to maintain their the DNS part of their data. And then also they will have to maintain things like WHOIS. Now, WHOIS is a service. Nowadays, there's another new protocol that has that is actually replacing WHOIS, called Registration Data Access Protocol. That's called RDAP. But anyway, this information is sort of public information. So when anyone gets a domain name, this domain name information is registered publicly, because these are all public resources. Whether you're talking about domain names or IP addresses, things like that, these are all public resources. So that is why the details has to be registered in public databases, so that in case if someone has to know exactly what's happening with these resources and things like that, there is always there's a way to check those things. And now here you can also see, let's now go into the client. Say, for example, here you can see a user here in the other far end. And if this user, say if this user want to visit a website or send an email or use a mobile app or something like that, then the user has to basically initiate a DNS query. And then this DNS query will go to, typically, say if they are connected to their ISP, this query will go to the ISP network. And then this ISP is supposed to provide an answer. So if this user is querying for, say, www.platformer.com, then obviously, like if this user to download the web page of platformer.com, you need to actually talk to that web server. which is www.platformer.com. But to talk to the web server, of course, you need to know the IP address, because as we all know, the internet works based on the TCP/IP protocol, and in TCP/IP you have different stacks. You have the application, you have the transport, you have the IP or the network, basically, and then you have the physical, the bottommost layer. Now, DNS resides in the top layer, the application layer, whereas the IP address, actually, that is in the IP layer. So if you have to then talk to another server, obviously you have to have the IP address, and that is why in the first place we need some mechanism, because IP address cannot be remembered by everyone. So that's why we need some sort of a mapping or a mechanism to actually for a human to deal with these requests quite easily. So rather, instead of remembering an IP address, obviously we can easily remember a domain name. So we have a mapping between domain name and an IP address. But anyway, the query happens, of course, to send the data or to download the web page, you need to have the IP address. So this user has to get the IP address. So who is going to give this user the IP address? In this earlier example, I was telling you that this is the ISP network. So they have to have a DNS server that will return the appropriate IP address of the web server of platform in this case. So once this user gets the IP address, user can, of course, visit the website and download the web page and so on. I mean, that happens whether even if you have to send an email, or even if you have to use a mobile app. It's all behind the scenes. It's all the DNS queries that happens. Now, earlier I was telling about this server actually that ISP maintains. So those sort of servers are typically called resolvers, DNS resolvers, or DNS recursive servers. And so those recursive servers would go out to the various other DNS servers out there. If you remember that hierarchical structure that I showed you before, I talked about root, I talked about .com, I talked about example.com, and so on. So if any of those entities, if they are keeping a certain database, certain namespace, they are authoritative for that. They are authorized for that. And obviously, they have to keep this namespace in a server, and that server is called an authoritative server. That's why you will see here called authoritative server here. Now let's try to actually zoom into this picture more. So now this is that last component that I was talking about. So you will see there are several elements here. This is that user, the client, right? So the client could be accessing, say, the web page, or it could be that through a browser, or the client could be using a mobile app, and things like that, right? And so so we have a resolver running there, and that resolver is actually simply in DNS terms, we call it as a stub resolver. And so this stub resolver, or simply the client, basically, so the client will send a DNS query to this recursive resolver, right? So that's the recursive resolver. So typically this recursive resolver is managed by an ISP. But there are, of course, public resolvers as well. Those public resolvers, for example, if you have used Google 8.8.8.8, that's a public DNS resolver. Similarly, Cloudflare, they have like 1.1.1.1. It's like these ones are all public resolvers. So either you can use one of those public resolvers, or you can still use a resolver managed by the ISP. We also call this as a recursive resolver, because the type of query it is doing is actually a recursive query. That means it would go and talk to multiple authoritative servers to find an answer. So in this example, say if the client is asking a certain question, as I said earlier, give me www.platformer.com. So that query goes here to the recursive resolver. Say that if you are connected to your ISP, so this would go to your ISP recursive resolver. Now the ISP recursive resolver has to provide you an IP address. So that IP address has to be found by this recursive resolver. So how to find that IP address? Because recursive resolver knows that you ask the question www.platformer.com. So it knows that the DNS hierarchy is like root.com, platformer.com, and so on. So it knows that top of the hierarchy is actually root. So this resolver then will go and talk to the root servers. And so I told you about root servers before. It will ask the question, okay, I need to get the IP address of www.platformer.com, but root server would not know that answer because root only knows about the delegations to these top level domains like .coms or .lk and so on. So root will respond with the IP addresses of, say, TLD servers like .com servers or .lk servers. And then
Champika, is it okay to interrupt for a question or?
Sure. Yeah, anytime.
Yeah, someone has asked a question.
Sorry, I can't see the chat window.
That's okay. Tivankar, he has asked a question. When certain ISPs block websites, how do they do that? Is it done at the recursive resolver level?
Okay, yeah. So, say for example, in many countries, like the regulatory authorities, they have certain policies. It could be that maybe certain sites should not be visited, or things like that. Even ISPs could be having their own policies. Say, for example, the ISP can think the user should not go to certain malware sites, or the users should not go to say some child pornographic sites and things like that, right? So they could be having their own policies as well. So in that case, they can always do some filtering here, actually, because if the client is sending a certain request, say in this case www.platformer.com, and in case if there is some certain restriction to this platformer.com, obviously this ISP can filter that and give either redirect this user to a different site, or not give an answer at all. That can be done. So that filtering can happen, of course, at recursive server level. That is possible. Yeah, I hope that answers the query.
You carry on, Champika. Yes, he has said yes, it has answered the question. Yeah.
And so that is actually at the ISP level. But of course, when it comes to filtering, there can be filtering done at various levels as well. And but here I'm specifically telling about the filtering done at the DNS level. Now, again, something for you to note is that when it comes to, say, let's take, for example, like Facebook, right? So in Facebook, you have different profiles. So if you have to filter a certain profile and so on, that that cannot be done at DNS level. But of course, if someone want to filter the whole domain itself, like facebook.com, that can be done at the DNS level, right? Because here we are talking about domain. But if you are talking about, say, the full path itself, that is not a domain name, right? That's a subdirectory structure. Yeah, so coming back to our topic, So I was telling that the query, how it gets resolved. So the ISP or the recursive resolver will send the query first to the root, and it simply asks, okay, I need to resolve www.platformer.com. And then root will say, sorry, I don't know the IP address of www.platformer.com, but I know the IP address of .com, right? So root will return the .com IP address to the recursive resolver. And then recursive resolver, once it gets the IP address of .com servers, it will go and talk to .com authoritative servers. And then it will ask the same question. I need to resolve www.platformer.com. And then the com server will say, I don't know the IP address of www.platformer.com, but I know where is platformer.com's name server is. So it will return the IP addresses of the platformer.com name servers. And then once this recursive resolver gets that IP address, it will go to the platformer.com authoritative name servers. And then it will ask the same question again, give me the www.platformer.com web server IP address. And then that record, that mapping, you remember earlier I told you that there's a mapping between name to an IP address, that should exist in the authoritative server of platformer.com. So, I mean, for simplification, I'm only just considering only one server. There could be always, of course, in the reality, there could be multiples of these servers. There could be clusters as well. So the answer, basically the recursive resolver gets the answer from the second level domain server in this case, which is platformer.com. And once the recursive resolver gets the answer, that answer is given to the client, because client is the one who asked that question. And then one very important thing it'll do, after that answer was given to the client, that answer will be kept in the memory of this recursive resolver, which is actually what we call the cache. So it's kept in the cache. So which means if this client, if this user asks the same question again, say if it asks, okay, I want to visit www.platformer.com again, this recursive resolver doesn't need to go to any of these authoritative name servers. It can straight away get the resolve the answer from the cache itself, right? So that's how it happens. I will actually, just to show you how this happens, I can, I just thought I will run a very simple DNS server. So I'm actually now running a very, can you see my terminal window, by the way?
Yeah, we can.
Okay, so I'm actually running a very simple recursive server in my machine. Now, also earlier, remember I told you that there are some public resolvers as well. So I have two options. One is that to resolve the DNS queries, I can either go to my ISP's DNS resolver. That is one option, or I can go to public resolvers like Google, Cloudflare, and so on, or I can run my own, right? So what I'm doing here now, if I my machine is of course configured to go to send the queries to public resolver, in this case Google, but I'm also at the same time I'm running another recursive server on my own, so I can show you the difference. I'm also using a tool called Dig. This is actually just to resolve. I mean, it's a tool to resolve DNS queries. So if I ask for, say, www, let's say platformer, I hope the spelling is correct. And okay, so you can see that it was pretty quick. It resolved the query very quickly. I asked, okay, give me www.platformer.com. So which means the query should first go from, you can see here the server is actually 8.8.8.8, which is actually the Google, because by default, all my queries are going to Google server, Google resolvers. And that Google resolver will first talk to root servers. There are a lot of root servers scattered around the world. Maybe also, actually, since we are talking about root servers, I should also show you that. Probably I'll open my browser. If you go to rootservers.org, you can see actually there is a map here. Let's try to these are all root servers scattered around the world. There are over 1,000 root servers scattered around the world because we need to have a lot of redundancy and also actually a lot of load balancing and things like that. Otherwise, in case if you only have only one root server, and if the root is down, that means the whole DNS that fall apart, right? So that is why that we can't afford. So this is why there are lots of root servers scattered around the world. So if you actually zoom into, let's zoom into like Sri Lanka. In fact, I've been involved actually putting some of these root servers in Sri Lanka as well. So we had few of those root servers over the last number of years. So you can see actually in Sri Lanka, there are 6 root servers. So there's a certain naming convention actually to name these root servers. It starts with the English alphabet letter, A, B, C, like that. So there are like 6 of the root server instances in Sri Lanka. In fact, actually, L is operated by ICANN. Actually. So mostly when in Sri Lanka, if you do any DNS, basically if you want to access internet from Sri Lanka, all your queries first, I mean, it goes to ISP or any public resolver, and then most likely that query will go to one of these root servers in Sri Lanka itself. If you take, we put the first root server back in like 10 years ago. Before that, there were no root servers in Sri Lanka. And before that, if someone want to actually basically access internet, the queries had to go outside Sri Lanka and then find the TLD IP address and return back to Sri Lanka. So as you can see, DNS response time is not the greatest. So now when you have a lot of these root servers in the country, like in this case, there are 6 root servers in the country. So DNS queries can resolve very fast. So that's something on the root server side. Let's go back to our terminal window. So in this case, I was looking for www.platformer.com. So my query first went to root servers. Basically, the Google servers talked to the root servers, and then the root servers gave the answer of .com servers. And then you can actually trace this. If you trace this, you can see actually how this query happens. Don't worry about some of these lot of other parameters, but you can see that first the query goes to this dot by this dot. What we define is the root. So there are, these are all those numbers. Remember, you saw that there was that L and E and so all those letters. So these are all the root servers. So the query would first go to root servers, and then after that, root is giving this Google server the IP address of the TLD, which is in this case .com. That's the TLD. And then these are the .com name servers. So this G, gtldservers.net, F, gtldservers.net. These are all the .com name servers, authoritative name servers. And then these authoritative servers will return, because .com will return the platformer.com. And then platformer.com, you can see that your name servers are here, like in Google Cloud. And so these are the name servers. And then our Google resolver will talk to these name servers and find the IP address of platformer.com, which is this one, right? So that's how simply a DNS query works. So in this case, of course, I used the my default public resolver, but I'm running also my own one, which I could also do the same thing. So I'm calling my own local resolver as localhost. So you can see it's still resolved, and I got the same IP address. And now, if you remember earlier, I told you that in this slide that this recursive resolver keeps this answer in the cache, right? So now my resolver, I found this answer. I found this I found this IP address, and you can see there's a value here which is 300. 300. This is in seconds. That says 5 minutes. So my local resolver will keep this answer for 5 minutes. So if I ask the same question again from my local resolver, within 5 minutes, my local resolver will not talk to those root servers and .com and platformer.com servers and so on. So if I ask this question again, so now you can see actually, see the time difference for the query. Initially, it took 1,273 milliseconds, right? When I did the first time, because the query had to go to root, the .com, platformer.com, and then come back to us, come back to me basically. But now, second time, when I did the query, it was only 2 milliseconds, because now I am getting the answer from my own memory, on cache. So you can see actually the difference. And at the same time, you can also see this number has dropped down. Earlier, it was like 300 seconds or 5 minutes. So now it has dropped down to like 240, because, I was talking for about, about 1 minute or so. So that's that time difference. So if I do this query again, you will see this 241 would be even further dropped to like 185. Right now it's like 0 milliseconds. It's because it's all coming from cache. If I do again, it will further drop 177 and so on. So after
Champika, the one more question.
Yep.
Are there any differences between the name server and the recursive resolver?
Okay, now there are different types of name servers. Primarily, there are two types of name servers. Okay, let me go back to this slide. You can see it here, right? So if you see here, this one I say recursive resolver. This one I say authoritative name server. These are all name servers. Even get the list pointer. Even this one is a name server, right? This whole thing is a name server, but simply we call it recursive resolver because that's the server that resolves the query, right? And this one, we don't call it as a recursive server or a resolver because it's not resolving our query. It is actually, it is authoritative for a certain answer. Say this resolver goes and talk to root, and root is the one which is authoritative for these TLD IP addresses. Because so what? Let's go from bottom. Now, when platformer.com, when you get your domain name, you have to run a DNS server. We saw that earlier, like you were running Google Cloud, right? So you had those 4 name servers or multiple name servers. So now you will have to provide those name server and the IP address details to .com, because those information has to be put into .com database. And then similarly, .com name server names and IP addresses has to be given to root, so that root will put those information in their database. So everyone has got a database and they are authoritative for that. So that's why we call those servers as authoritative name servers. But this one doesn't have any authoritative database as such. It is just doing a very simple job of resolving the query through a recursive. The query is basically a recursive query. Recursive query means it would go to this server, this server, this server, and find the answer. And that is why we call it a recursive resolver. Sometimes these servers also in some documentation, some books and things like that, you will find that This server is called a recursive server. Sometimes this server is called a caching server, or caching name server, recursive name server, recursive resolver. It's all, everything means the same thing, actually. But primarily, you will have two different types. One is actually called a recursive resolver, and then the other one is called an authoritative name server. So authoritative name server and a recursive name server, simply. Does that clear your question?
I think, Champika, there are a couple of others. Are you okay to take them? Or
yes. Okay. Let me actually have this chat window, because I only see my.
Yeah, I can read out, Champika, because if,
okay. Yeah. Maybe, yeah.
Yeah.
Okay. Great.
Regarding the recursive cache, how long they keep the cache? Is there an expiration of the maps they create for the request?
Okay. So that has to be set by the. So, for example, in this case, platformer, it is your DNS administrator. Your DNS administrator has set the value, the caching value, or this is what we call a TTL. TTL stands for time to live. So cache depends on the TTL value. So in this case, your administrator has set the TTL as 300. So which means in my cache, it will last for 300 seconds or 5 minutes. Let's go to a different site. Let's go to, I'll go to ICANN.org. So in our case, of course, there's a CNAME record, which is a canonical name. So over there, we have a TTL of 3,600, so which is 1 hour. So in this case, my recursive server will keep this answer, this record for 1 hour, this record for 1 hour, and this record for 30 seconds. So if I do the same query again, you can see that this has dropped now to 3,571, and this has dropped to 2. So obviously I spoke for more than 2 seconds now. So next time when I do this query, you will see this will be reset again to 30. This would be actually reduced to further, 3,400 something. So yeah, so 3,500 something. So further reduce. So in this case, actually, because I spoke for more than 30 seconds, that's why it reverted back to like 5. You can see that. See, now it's got back to 30 again. So that's how it works. So again, to answer your question, how long, it is up to the DNS administrator of the authoritative server who can set this TTL value. If you want, you can keep it for like 1 full day.
I think that has answered a couple of questions. The next one, I don't know how many slides you have to go through, Champika. The next one is there a possibility to show the local resolver setup?
Okay, yeah, it's a very simple resolver that I sort of created. You can see actually I have a zone file for my local resolver. If I open that, you will see, this is what we call a zone file, and these are called resource records. So simply what I'm telling here is that my local host has, that's the host name or the domain, basically. I just call it localhost. And then the IP address is my loopback IP address, because that's the IP address we use for the local host, which is actually 127.0.01. That's the loopback address. So that's the zone file. And then if I open this file, this is what we call root.hints. So if you see this file, now this has actually a list of root servers. So what this is saying, if I want to talk to the root, right? Dot means always the root. If I want to talk to the root, my query will go to a server called a.rootservers.net. If you remember, even in Sri Lanka, when I was showing those root servers, there were different letters, A and L and all that. So we have actually 13 names for these root servers. The first one is starting from A, the second one is B, third one is C, and so on. Everything has the domain of all those root servers are rootservers.net. And so simply what I'm saying here is, if my local resolver want to talk to root, go and talk to this root name server called a.rootservers.net. And then name is not enough. I need to provide the IP address because, obviously, as I said, the data communication happens in the IP layer. So I have to map this name to this IP address. As you all know, now we also have IPv6 addresses. So I'm also mapping this to an IPv6 address as well, because this root server has got both IPv4 address and IPv6 address. So even if I'm in IPv6 network, still I can get to that. So in the same way, I'm telling, I say, if there is no A root server close to me, try B root servers, right? And similarly, try C root servers, D root servers, and so on. So all the way up to, M or so. So if you count, all those, you'll see like 13 names, but physically we have, I told you, like over 1,000 because actually this is all implemented using Anycast technology, Anycast routing basically. So which means even though we have, say, L root here, only one name server and only one IP address, physically we have like over 150 servers or so, different parts scattered around different parts, and it'll get to the nearest server basically. So this file simply root.hints is referring to, because my local server has to know how to go and talk to the root server. So which means that's the purpose of this file. And next thing is I also have a file called named.conf. That is actually pretty, okay, let me clear this. So this one simply, what I'm, this is just a directory statement. I'm just telling that all my files are in this directory. And then I'm creating a zone statement. So if I want root, I'm telling go and talk to this root hints file. And then similarly, if I, for any purpose related to my local host, that's my file as well. Now, this is a very simple setup. But obviously, if I'm running authoritative servers, if I'm supporting, say, if I want platformer.com, then I have to, if I'm authoritative for that, I have to add those zone statements separately into this. So this is what we call a configuration file. When you run the name server, you have to actually run this name server. So in my case, I'm running a name server software called Bind. Bind is open source name server software, and again, there are so many different type of name server softwares as well. Some are open source, some are commercial. It's up to you that which one you prefer. And so you can also see actually I'm running Bind, and that's the process that I'm running, right? So if I want to actually stop my name server, I can just kill this process, which is this. So now if I do the same query, it would not resolve because my name server is down now. Okay, that's my query before. Let's go to the platform. Yeah. Now it's not working because my name server is down. And so what I, if I have to start my name server, of course, to run that, so I have to run the process, and that's my configuration file. So now I run my name server. You can see actually, you can see now the process is running, right? And then if I do the same query again, it should work. works, and then I get the IP address now, right? Does that make sense?
Yeah, I think in brief sense, I guess setting up the bind and everything is also a little bit of a you probably need to take a bit more time.
Yeah. So you might want to actually, again, as I said, there are different name server software. So this setup is actually, I mean, concept is all same as I explained you before. But of course, the files and directives and things like that can be different from one name server to another. And bind is quite widely used, mainly because of the reason I told you, it's open source and so on. So if someone is running bind, obviously it's good to sort of go through a bind reference manual if you want to get more information about those files and so on. And in the same way, for example, even Microsoft, they have Microsoft name service, and then similarly there are a lot of other Power DNS, and there are various other name servers as well. Actually, talking about that, there's a good Wikipedia document where you can compare name servers. Yeah.
There's another question related to that as well, Champika. This is if we use the local resolver, does that mean it's skipping the ISP resolver?
Yes. Yeah, in my case now, I'm not going to my ISP resolver anyway. It's resolving locally.
Okay. And the second part of the question is, can the ISP still track the IPs I'm visiting?
Yeah, because of course, right? Of course. See, okay, let's come back to our slide here. So now from here, so I'm here, and then this is my ISP. Now, still this traffic, right? This DNS traffic is going through port 53. So if this ISP is, of course, if they are monitoring port 53, they can see my queries. So if they want to block those, they can still do that. That is possible. But in recent times, there have been some protocols that has been developed. For example, there's a new standard protocol called DOH and DOT. DOH stands for DNS over HTTP, and then DOT stands for DNS over TLS. So basically, with that, because in that case you are sending encrypt, because now this query is not really encrypted, right? That's why they can see that. But if you encrypt this, then they can't do that. And so you will have to then obviously have to enable DOH or DOT in that case. Yeah. But then again, DOT works on a certain port as well. So if this ISP want to block all, say, that is actually that particular port, they can still do that. But in that case, everything will be filtered. But then DOH is pretty hard, because for ISPs, it's pretty hard, mainly because that is web traffic, because DOH is DNS over HTTP. So it goes as part of web traffic. So if in that case, if they filter the web traffic, that means you can't visit anywhere. So ISPs wouldn't do that. So in fact, actually, this is very recent. So this is why there have been a lot of discussions in recent times with different. Earlier, I told you, like, there are a lot of these policy-related discussions happening as well. So it is up to the community to decide or how these protocols should be used, and how resolve operators should be using these. And there are a lot of discussions happening at the moment. Yeah. But if you take a simple DNS query, which is not encrypted, so this part from client to the recursive resolver, that is clear. right? So if someone want to see that, filter that, the ISP can do that. Yeah.
Thanks, Champika.
Yeah. So actually, are you okay to if I take like 15 more minutes?
I think they should be okay, right, Nilesh?
Yeah, all good. Yep.
All right, okay. But I just want to quickly touch on a little bit of some security issues as well. So let me, I mean, nowadays you have seen a lot of these cybercrime related, issues, right? There are lots of hacks, DDoS attacks, and abuses, spam, phishing, all sort of things, right? So these things are very common nowadays, malware, botnets, and all that. But many of these cyber attacks can happen because the DNS infrastructure is not secure, right? Someone can abuse the DNS infrastructure mainly because DNS is public. It's publicly facing infrastructure, and as I said earlier, even if you have to send, browse the internet or send emails, use mobile apps, you still have to use DNS. So this is why a lot of cyber criminals, they target DNS. And one of the attacks, one of the reason for most of these attacks is something called cache poisoning. So cache poisoning happens earlier. If you remember, I was talking about these caches, right? So for example, my resolver keep the answer in my memory, in my cache. But if an attacker managed to poison that cache or pollute that cache, then instead of me, say for example, now I'm keeping the platformer.com IP address, that 35, whatever that IP address. But in case if my cache is polluted, to keep a different IP address, then next time when the client asks a question from me, I will return a wrong IP address. So when I return wrong IP address, obviously client will go to a wrong website, not the platformer.com website, but it will go to a wrong website. So this can happen to a bank, for example, so the credentials can be, stolen. And then this happens everywhere, like social media sites and phishing attacks and things like that. So that happens because of this cache poisoning. Then we also have this thing called domain or the DNS hijacks. So this is where an hacker or basically someone could hijack the recursive server or recursive resolver. So, say for example, if someone is running a recursive server, and then that can be hijacked so that the queries will not go to your intended recursive server. Instead, the queries will go to a wrong server, which is run by an attacker, for example. I mean, this can happen, say, for example, in a, we all the time, we use connectivity in public places, say in restaurants and airports and things like that. When you connect to, say, if you connect to a certain Wi-Fi network, your queries, your DNS queries could be going through that infrastructure. So they could be providing the recursive service as well. So if they manage to actually, the thing is that how do you trust this? In the first place, if it's in a public place, you don't know whether this is a genuine recursive server or not. So if they are not really a genuine server, and if you want to ask your bank web server IP address, they can easily give you a wrong IP address of a phishing site, where you would go to a phishing site and provide all your credentials there. So these kind of things happen. These are pretty much, DNS hijacks as well. And then, if the domains are compromised, then one would see all the web traffic coming into that domain, and then a lot of information can be derived out of that. It is easy to actually to communicate with botnets as well, because sometimes, when some malware sites, right, malware infected site, for example, when they want to talk to a bot herder, so they would talk there are some certain malwares, they would talk through DNS, basically through port 53, because some firewalls would still love that, because they would think that it's still DNS traffic. So these kind of security issues can be there. And then obviously even your sanity checks, say for example that when you get your own domain name, you have certain access to your domain name registrar. Remember earlier I was talking about registrars and so on. So registrar would give you a certain portal access. So you would log into that portal, and then if you change your name server entries, you will have to actually change those IP addresses and name server entries and things like that. But if someone actually, if an miscreant manage to get through a phishing attack or something, if they can get your credentials and get to the registrar portal, they can change all your DNS settings. If they change your DNS settings, they can change your DNS name server IP addresses, they can change your mail server IP addresses, so you will not receive and even get the mails, they'll redirect to them. So all sort of things can happen as well. So this is why always it's something that you need to be very careful, especially dealing with your registrar interfaces. Also, you should also have things like registrar locks enabled, so that in case because some of these hackers, once they get into registrar, they could even transfer the domain to another registrar as well. So these things can be prevented by there are things called registrar locks that will prevent domain name transfers actually between registrars as well. And some of the attackers also, they are quite smart enough, when they have all this domain related information, they can even go to a certificate authority and get the SSL certificates, right? Because there are some certificate authorities who may not really check very thoroughly before issuing SSL certificates. So they might even have SSL certificates to their hijacked domain or the phishing domain. So sometimes a user may not be able to really tell whether this is a genuine site or not. So basically, DNS contains quite a lot of information about your systems, about your data. Say, for example, your organization domain name, that is there, and then your individual host names, your mail server names, your web server names, and all that, and then the related IP addresses, your database servers, their locations, and all those things. These are all part of the DNS database anyway. So if the DNS is exposed, many of this information can be in a sort of you are in a risk basically. So anyway, just to sort of summarize, there are lots of potential target points in your typical DNS infrastructure, right? So earlier we talked about stub resolvers, the recursive resolvers. So this is the user. User would talk to the recursive resolvers. Recursive resolver would talk to authoritative servers, and then that path between those servers. And then this is the registry system. Remember, we talked about registrars. So registrars will have to send all your updates. Say this is the user, say for example, right? So if you update your name servers through your web interface, it goes to the registry database, and the registry has to update the registrar has to update the registry, because ultimately registrar is a intermediate body, so they have to get the details from you and update the registry database. So when the query happens, obviously these authoritative servers will talk to the registry, right? And registry is the one who provides this information. So this communication has to be secure as well. So all these points, actually, there are some threats where someone can attack basically your DNS infrastructure. So when you try to protect your DNS infrastructure, you have to basically protect everything, right? Otherwise you can always be in a risk. Now, just want to actually finish by sort of touching this very important security mechanism what we have in DNSSEC. In DNS, it is called DNSSEC. DNSSEC stands for Domain Name Security Extensions. DNSSEC. So this would actually provide very two important security goals. One is called authenticity, and the other one is called integrity. So authenticity is actually, are you talking to the right party? So if you are talking to a particular authoritative server, say .com server or platformer.com server, are you really talking to the right server? Because someone could have easily, as we discussed earlier, someone could have hijacked it. It could be that we could be talking to a wrong one or a fake one, right? So we have to make sure that we are talking to the correct party, correct entity, correct server. So that is what we call authenticity, right? And then we have integrity. Integrity is when I send something to you, you get that in the same way that I sent. So nothing is modified in the middle. So you get the same stuff, right? So things like checksums, for example, right? When we download softwares, we check the checksums. And so we also have to make sure that integrity is all intact. Otherwise, man-in-the-middle attacks can happen. Say, for example, the cache poisoning type ones. In the middle, the IP address of the, say, the bank web server can be changed to something else. So if the bank web server IP address is changed to another IP address, obviously the integrity is lost. So we should be able to identify that. So DNSSEC is a mechanism. It's a security mechanism that helps us to identify, or basically it helps us to achieve this authenticity and integrity, right? So this is a very important security mechanism. What we try to do here is actually, if you remember that zone files that we have, the databases I talked to you before. So this, we digitally sign the data inside this. So, when you have, say, if you take platformer.com, in your platformer.com name servers, if you remember those, the Google name servers that you had, all those name servers, they keep information about platformer.com. So if you want to deploy DNSSEC, that means, all those data, say about your www.platformer.com or your mail server records and all those things, they all has to be digitally signed. So when you digitally sign this, after signing, what you would do is you would publish your public keys, and then whoever received this data, the clients, right, or the recursive resolvers, when they receive this data, they can validate the signatures, because signatures also has to be published in your zone. So with these signatures, because the public keys are published, we can verify whether these are proper signatures or not, right? So that's the simple technology, basically, cryptography. That's what we use, and using that we can achieve authenticity and integrity. So I think maybe along the line, if you have not deployed DNSSEC, maybe this is something that you can always consider. This is just a sort of graphic to show without DNSSEC and with DNSSEC. So without DNSSEC, as I said, your query can, this is the real site, say the majorbank.com. The query can always, through a cache poisoning or something like that, the query can always go to a attacker's site where they can capture all the credentials and so on. But if the DNSSEC is deployed, always this data, because this this server IP address is different, and that means integrity is lost. So obviously the client will not be, the recursive server will not give the IP address to the client, because validation would fail. And this is why earlier when I did that query, if I go back to that query I was just showing you earlier, that So if you see this, so like these ones, right? So you can see all these records. So this RRSig means it's a resource record with signature. So this is actually a signature. So we have a signature here, and it is because this record is all digitally signed, and recursive resolver can validate whether this signature is really correct or not, or it belongs to the party which is claiming to be that party. And yeah, so that's about DNSSEC. And so just to sort of want to finally summarize here, what you can do as an organization, if you are an organization, it's always worthwhile to sign your corporate domain names, and then also if you're running DNS resolvers, right? Because some organizations, they run corporate DNS resolvers. Always it's a good practice to turn on DNSSEC validation in the corporate DNS resolvers. And for users, if you are a generic user, maybe you can always ask your ISP to turn on the validation, so that at least you are sure that your ISP will give you a right answer and not really a fake web server name or fake web server IP address, basically. And then, of course, there are education and training opportunities along this line as well. And if anyone is even interested, maybe later on we can even do some sort of detailed session on DNSSEC as well. I think, yeah, that's all what I wanted to basically cover. If you have any further questions, you can even contact me. That's my email address as well. And I'm happy to take any questions if you have now.
I think there's one question. You briefly touch on the DNS resolution over HTTP, right?
Yeah.
How does that? What's the path to that, Champika? Is it still goes and hit the recursive resolver, or is it bypassing the recursive resolver?
Yeah, you mean that DOH?
Not DOH. There was another one, right? You mentioned TOR?
DOT?
DOT, sorry, yeah.
Yeah, so it will still go to the resolver, because anyway, a resolver has to resolve that, right? It could be going. It is not a must that the DOT resolver. I mean, the resolver has to be your ISP always.
Yeah.
It could be somewhere else.
Mm-hmm.
But ultimately it has to be resolved by a resolver. Yeah.
So I guess maybe I didn't put it that in the correct way. So if you actually use the DOT, which is you said over HTTP, right?
No. DOT is over TLS. Actually, this is a transport layer.
DOH is the one is over.
Yes, HTTP.
So if you then, that resolver is, let's say, Google, but not your ISP, right?
Yeah.
Your ISP cannot kind of block it, right? Because if they block, it's going to block your...
Yeah, because they can't block it because it's all encrypted. They don't know what is it, right? Because it's all encrypted.
Right.
And so this is actually the implementation of DOH would be really tied up with your application. So it in this case it could be a browser.
Right.
So in your browser, so you will have a resolver built into your browser.
Mm.
So your browser will send the queries to a certain resolver that to do that resolution. And until that point, everything is all encrypted. So even it goes through ISP, your ISP do not see that information.
Okay. If they're going to be blocking at the ISP level, they'll have to block, like, I guess maybe, I don't know whether the question was related to some countries blocking like social media sites. Mm-hmm. So browser, you're doing the resolution through the browser, and the resolver is completely outside of that country or the ISP, right?
Yeah.
Which means the only way the ISP can actually block the entire IP range, right?
Yeah. So basically, they can't block based on the DNS traffic because they can't see that. It's all encrypted.
Yeah. Okay. If there's anyone else has any other questions other than what's all asked before, and I mean, in the future, like if you're like interested digging in, I mean, this is very relevant to Kubernetes as well in some sense, Champika, because within the Kubernetes cluster there is local DNS. That's all the resolution within the all the service discovery and everything.
Yeah.
And I guess there won't be any DNS, right? Otherwise,
I mean, of course, there's if someone is really interested into more of DNS, there are sort of more things we can do in the configuration level, and but we can if someone is interested, I'm happy to even if you have any questions, we can take those, and later, or even we can do another session as well.
Yeah, well, we'll ask around. And I guess the last question I have is that I don't think even we have enabled the DNSSEC. So you highly recommend to enable the DNSSEC for the corporate domain?
Yeah. So in your case, obviously, like I mean, I took platformer.com because you guys are the host, and but I'm sure there are a lot of others who are here who probably have different domain different domain names under different TLDs or under different country code top level domains and so on. But only thing is, actually, I mean, we didn't talk too much details into DNSSEC. Now, for DNSSEC to work, say if you deploy DNSSEC in platformer.com, you have to propagate the trust to .com, right? Because above you, your parent is actually .com. Yeah. So you have to sign your domain, platformer.com. You have to sign your zone, and then you have to actually propagate your trust. Trust, in a sense, actually your keys, basically. And again, we have to hash those keys and then propagate that to your parent, which is .com in your case. So if someone here, let's say someone else has got a .lk domain, they have to propagate it to .lk, actually, because .lk is their parent. And so for DNSSEC to work, the whole hierarchy, all the way up to the root, they have to understand DNSSEC. Which is actually pretty good. Now, root has deployed DNSSEC for like last more than 10 years or so. So that's not a problem. And even if you take top level domains, currently about 90% of the top level domains in the world, they have deployed DNSSEC, except some country code top level domains, some CCTLDs who has not yet deployed. But from Sri Lankan perspective, .lk has deployed. So if someone here having .lk domain, it's not a problem as well. So you can always sign your second level domain. So even for .com or .lk, it's not a problem because both .com and .lk has deployed DNSSEC, so they can receive the trust from you, and then they can put your keys into their zone and then sign it. So that's not a problem.
Okay. Thank you. Anyone else has any last minute questions? Otherwise, we can probably wrap up. And there's a recording as well, so we'll share with you as well as with the others as well. Nilesh, over to you, I think, if there are no questions.
Yeah, if there are no more questions, thank you very much, Champika, for this valuable session. We learned a lot, and you will be sharing with us the presentation slides as well.
Yeah, I can share the presentation slides as well. Yeah.
Okay. And
Mm.
I hope in the future also you would have some time to come and do another webinar session on
Yeah. We can do that. Yeah.
Thank you. Thank you very much, Champika. Thank you, Kanchana, and thank you for everyone who tuned in. Thank you very much.
Okay. Thanks very much, and it was very nice
Appreciate
talking
it.
to you all.
Checking
And let us keep in touch as well.
Yeah. Thanks again.
Bye-bye.
Bye.